Hey everybody, welcome back. This is lesson 3.3, solving systems of linear inequalities. The objective for today, you're going to be able to learn how to solve systems of linear inequalities. And surprisingly, your vocabulary for today is system of linear inequalities. So, what exactly is a system of linear inequalities? Well, when a problem uses phrases like greater than or no more than, you can model the situation using a system of linear inequalities. And finally, a system of linear inequalities is a set of two or more linear inequalities with the same variables. The solution to a system of inequalities is often an infinite set of points that can be represented graphically by shading. When you graph multiple inequalities on the same graph, the region where the shadings overlap is the solution region. So let's do a few examples. The first one just says graph the system of inequalities. And as you can see, we've already got our two equations solved for y. So these are going to be relatively easy to graph. And as you remember, the y-intercept in this case is -3. So when x is 0, the y is -3. So we'll just go 0, -3. And it says rise 1, run 2. So rise 1, run 2, rise 1, run 2. And notice that this is not equal to, so we're going to have a dashed line. So there it is. All right, and it says that y is less than that, so let's just shade down below, the y's down below. There you go. All right, the next one says y is greater than or equal to -1x plus 2. So when x is 0, y is 2. And it says we're going to rise over run, -1, 1. All right, and -1, 1. All right, and this one says greater than or equal to, so this time our line is going to be a solid line. There it is. And it says y is greater than, so we need to shade above the y. All right, so there's our shading. And as you notice, we have a region here where all of the points are shaded in. All right, and so this is going to be our solution set. But we always want to check and make sure. So let's just choose a few points that we'll check here in a minute. The easiest one to check is going to be our left, furthest most left, and let's just check 0, 0. Okay, and that's going to be on our left. All right, the left quadrant. We're going to also try our right quadrant. Let's try 5, -2. So 1, 2, 3, 4, 5, 1, 2. And this right one, okay, so this is our left, this is our right, and we expect that this one to actually work for us, 5, -2. We also should check the top. Let's try 0, 3 up here. Top is going to be 0, 3. And let's try something in the bottom quadrant, which would be, let's say 0, -4. So that's going to be our bottom. Okay, 0, -4. So now what we're going to do is just put each of these coordinates back into our equations, and we want to check to make sure that this right point right here, for sure, 5, -2, is the solution that is true. So just in the interest of time, let me just remind you, the overlapping region is the solution region, but let's check it to make sure. And I've already done all of the problems for you here, so we're going to just kind of zip through these. When x equals 0, y equals 0, when you put it in your equation, you get 0 is less than -3, and that's not true, or 0 is greater than 2, and that's not true. And we said in that left in this left quadrant here, where 0, 0 is, that it should be not work, and it does not for either of them. Okay, let's go back. So there's the 0 when 5 and -2. Actually, that's the right one, and that's the one that we had hoped would be true. And indeed it is, and you could check the other two. You can turn the video off and check the math if you'd like. but we can see in the top one only one of the equations is true, and in the bottom only one of the equations is true. So we verified, this was just to verify, that the point in the right region is actually the one that satisfies. So the only point from the overlapping right region satisfies both inequalities. All right, if you're unsure which direction to shade, you can always use the origin as a test point. Just a helpful hint there. All right, here's another problem. It says graph each system of inequalities. So again, we've already got it set to y, so this is pretty easy. When x is 0, y is positive 2. And we're going to go down 3 and over 1. So let's go 1, 2, 3 over 1. And that is not included. It's just going to be a dashed line. And there it is. And our next one says y is greater than negative 1. So what that means is when y is 1, everything else is going to be, all of our points are just going to be right here. Y is always going to be negative 1. So let's just plot that in. Oops, I forgot to shade in on the top one. So here's our next line. It says y is greater than negative 1. So we're going to shade up in this top region here. And there we go. So the area where it's shaded in both places in here, this is going to be our region where our solution is. The overlapping region is the solution region. And once again, we want to check a few points to make sure. I'm just going to check this 0, 0 here. That's the easiest point to check. So when y equals 0 and x equals 0, we actually have 2 is greater than y, and that is true. And when y is 0, again, we don't have an x to worry about, but y is indeed greater than negative 1. So both of those are true and tell us that by using that test point, we see that the solution is correct. All right, now a little bit trickier one. This one is for you to try on your own. This time you're going to have to solve for y first. So go ahead and turn the video off and try and solve this one on your own. Okay, welcome back. Hope you were able to give that a try. Let's just solve this real quick. When you have x minus 3y is less than 6, let's just do that. X minus 3y less than 6, and remember we want to solve for y, so we're going to divide both sides by x. I'm sorry, we're not going to divide both sides by x. We're going to subtract x from both sides. Minus x, so that leaves us with negative 3y is less than negative x plus 6. And next we have to, we need to divide both sides by negative 3. And remember, when we divide by negative 3, we have to change our sign. All right, and that gives us positive 1/3 x plus a negative 2. All right, so let's go ahead and figure out where that would be. When x is 0, y is negative 2, so there's our y-intercept. We're going to rise 1, run 3. And so there's that. And this is going to be a dashed line because it's not equal to, and there it goes. And this says that y is greater than, so let's see, there it is, y is greater than. All right, let's solve our next one. Should be 2x plus y equals 1.5. All right, and let's subtract 2x from both sides. So that leaves us with y equals, and actually it should be greater than. Let's get that right. Y is greater than negative 2x plus 1.5. All right, so let's plot that. When x is 0, y is going to be 1.5. So let's go there. It says we're going to go down 2 over 1. So 1, 2 over 1. All right, and this one is again just going to be a dashed line, so let's get that in there. There we go. And it says y is greater than, so we're going to shade everything up above the line. And there it is. All right, so the overlapping region is our solution region. And again, we need to take points to check them all. I'm not going to do everything, but I'm going to choose some points here. And let's see if it's 0. Let's choose a 0 here. 0 minus 0 is indeed less than 6. But let's look at this one. 0 plus 0 is greater than 1.5? No, and that's why we see that it is not in the overlapping region. All right. Let's choose one that's in the actually, yeah, let's choose another one. Let's choose 4, negative 2. Let's see, 4, negative 2. All right. And let's choose 0, 3 up here, and this is the one that we want to be true because it's in the shaded area. And then we'll also choose 0, negative 4. And again, I've just already done these, worked these out for you because this is just some pretty simple math here to do. So the main one that we want to make sure that's true is this one that's in the shaded region, and that's going to be the 4, negative 2. So here's your points here. We already checked for 0. And there's the 4, negative 2, which we find out 10 is less than negative 6. That's not true. Oh, this is the 4, negative 2. This isn't the one that we needed to be true. And 6 is greater than 1.5. That one's true. Let's try the 0, 3. That one, negative 9, is less than 6. And 3 is greater than 1.5. So this point here that was 0, 3 is actually the point that is true. And I'm going to go back to that back page just a minute. Let's go back there. And here we see 0, 3 is the true one that we wanted to be true. All right, so all of the rest of them are going to show that they are not true. Only the point from the overlapping top region satisfies both inequalities. All right, I don't have any more long charts like that. Let's keep going now. All right, the next one's, I want you to try this one on your own again. So put the video on pause and give it a try. All right, so when we do this one, we see that the first one's already set up where y is equal, or actually it's less than or equal to 4. So let's go ahead and plot that. Here y is going to be 4 no matter what x is. Y is going to be 4. And this is equal to, so it's going to be a solid line. And it says that y is less than, so we're going to shade everything below. There it goes. All right, and then the next one we need to solve again. So we have 2x plus y less than 1. All right, let's subtract 2x from both sides. And we end up with y is less than negative 2x plus 1. So let's go ahead and graph that. When x is 0, y is 1. And we're going to go down 2 over 1. Down 2 over 1. And this one is going to be a dashed line because it's not equal. There it is. And this one says y is less than that. So we're going to do everything in the less than side. And notice that everything in this green that shares the shading is going to be part of our solution. So let's just choose this 0, 0 again. I always like choosing that one's easiest. So 0 is indeed less than or equal to 4. And over here, this would be 0 plus 0 is 0, and that is also less than 1. So we know that the solution in the shaded area, the overlapping region is the solution region. And the test point, which we just did, satisfies both inequalities, so the solution region is correct. All right, let's do some word problem examples. Let's go. Lauren wants to paint no more than 70 plates for the art show. It cost her at least $50 plus $2 per item to produce red plates and $3 per item to produce gold plates. She wants to spend no more than $250. Write and graph a system of inequalities that can be used to determine the number of each plate that Lauren can make. All right, well, let's get started with this. Let's start with some of the simple things that we know. Let's say that x is going to be the number of red plates. All right, so x is going to equal red plates. And let's say that y is going to equal the total of gold plates. All right. So let's try and come up with a couple of inequalities if we can. The total number of plates that Lauren is willing to paint can be modeled by the inequality. She's going to paint X red plus Y gold, and she does not want to paint any more than 70. So we're going to say that's got to be less than or equal to 70. All right, let's see if we can come up with another inequality. It says that the amount of money that she's willing to spend is going to be $50 plus 2 times the red plates plus $3 times the gold plates, which is Y, and she doesn't want to spend any more, so that means she's going to be less than or equal to $215. And all of these should have dollar signs on it, but I'm not going to do that for us right now. There's actually 2 more inequality statements that we could make. We know that she is going to make red plates, so X has got to be greater than or equal to 0. And Y, we want that to be greater than or equal to 0 because she's not going to make negative plates. So here we have 4 inequalities. All right, 4 inequalities right here. And so what we want to do is we want to write and graph a system of inequalities that can be used to determine the number of each plate Lauren can make. So we've written them out already, so now we need to go to getting them graphed. All right, so here they are again. I've written our inequalities back up here. X is going to be greater than 0 and Y is going to be greater than 0, so we're able to make our graph look a little bit different. We don't need to have any negatives on here. So let's get started. When I look at this one, this X plus Y is less than or equal to 70. I know I can use my intercepts to plot that. And so if we think about what that means, if I just take X and Y, and I'm going to use my 2 intercepts. So I see when X is 0, this is 0 plus Y is less than 70. So Y is going to be at our 70. So 0, 70. So let's plot that point. And when Y is 0, we can say X plus 0 is going to be less than 70. So X is going to be less than 70. So let's plot our X at 70. All right, and this is less than or equal to, so we get to use a solid line. There we go. And it says that it's going to be less than that, so we're going to shade down below. All right, our next equation is a little bit more, slightly more interesting, but not by much. So we have 50 plus 2x plus 3y is less than or equal to 215. So let's subtract 50 from both sides, and that leaves us with 2x plus 3y less than or equal to 165. All right, again, I'm just going to use our intercepts to help us. Here's a t-chart. Oops. So let's say when x is 0, what is y? So that would be 2 times 0 is 0, so that just leaves us with 3y less than or equal to 165. Divide both sides by 3. So that leaves us with y, and when we divide 165 by 3, we actually get 55. So our y is going to be at 55 here, and we'll put that in there. Let's see what happens when y is 0. All right, when y is 0, we're going to have, again, let's just use this part of the equation, 2x plus 0, which is 3 times y, it's got to be less than, let's see, 165. So let's divide both sides by 2. So x is going to be less than, and that's 82.5. Whoa, there we go. All right, let's see if I can bring that back down. All right, 82.5. All right, and actually the book doesn't quite put it in there quite right. This is less than or equal to, so it's going to be a solid line. And it says less than, so we want to shade down below. So when we're looking to see what our solution could be, it's just the area that has all shaded from both sides. So it's going to be this entire area here. All right, and we can choose something in this area to prove out. Let's use the point 2020. That's about right here. All right, so if we say x is 20 and y is 20, so 20 plus 20, and we want that to be less than or equal to 70. We know that 40 is indeed less than or equal to 70, so that one's true. And let's put it into here, this other equation. 2 times 20 is 40. 3 times 20 is 60. So 40 plus 60 plus 50 is 150, and that is also less than or equal to 215. So we know that our solution is true. All right, so once you get this one, try on your own. Turn the video on pause, and then when you're finished, turn it back on, and let's get going. Okay, so let's do this problem together. It says, Layla is selling hot dogs and spicy sausages at the fair. She has only 40 buns, so she can sell no more than a total of 40 hot dogs and spicy sausages. Each hot dog sells for $2 and each sausage sells for $2.50. Leela needs at least $90 in sales to meet her goal. Write and graph a system of inequalities that models this situation. Okay, so let's let D equal the number of hot dogs. D equals hot dogs. All right, and let's let S represent the number of sausages. There we go. All right, so the total number of buns Layla has can be modeled by the inequality D plus S, hot dogs plus sausages, has to be less than or equal to 40, because she only has 40 buns, so she can't sell any more. All right, and we also know that the hot dogs are $2 each, so 2 times a hot dog plus 250, 2.5 times a sausage, all of that, she wants to make at least, so she wants to make more than $90. All right, so let's see what else we know about this. We know that she's going to sell, she won't sell negative hot dogs. So we know for the hot dogs it's going to be greater than or equal to 0. And we know the same thing for the sausages are going to be greater than and equal to 0 also. So we actually have 4 inequalities that we can gather from this statement here. All right, so we've actually done the first part. It says write a system of inequalities, and now we're going to graph them. So I've taken those inequalities and moved them over here, and let's go ahead and graph them. The D is greater than 0 and the S is greater than 0. It fills out our entire chart, so everything gets filled on that one. So we're more concerned about our hot dogs and sausages. So let's start with our D plus S is less than or equal to 40. Let's go ahead and make a T-chart, X and Y, and let's just solve for X. Well, when X is 0, or not, we're going to call that D and S. Let's erase that. D and S. So when D is 0, 0 plus S, 40. So let's put 40 for our S. Okay, the dogs are 0 dogs and 40 hot dogs. Okay, so there's one. And the same on the other side, when I sell 0 sausages, that means I have sold 40 hot dogs. All right, and this is going to be inclusive, so we're going to have a solid line. So there it is, and it says that this has to be less than, so we're going to shade everything down below. All right, And now our next equation says 2d plus 2.5s has to be greater than 90. So again, let's do our quick little t-chart. When the hot dogs are 0, all right, that goes away. 2 times 0 is 0. We have 2.5 times s is greater than 90 or equal to. And we want to divide both sides by 2.5. So that tells us that s is equal to 45. Okay, so when our hot dogs, when we sell 0 hot dogs, we have to sell 45, 0 hot dogs. Put it on the wrong spot there. We sell 0 hot dogs, we sell 45 sausages. And when we sell 0 sausages, that leaves us with 2d is greater than or equal to 90. Divide both sides by 2. So d is greater than or equal to 45. So let's go ahead and get that in. See, 30, 45. And this one is going to be up here. I didn't count my numbers quite right. All right, and again, this one is going to be a solid line. Oh, what did I do wrong here? Got the 45 right. Let's see. 90 divided by 2.5. 90 divided by 2.5 equals 36. So there's where the problem is. Okay, so, and this again is less than, so let's shade it down. Oh, nope, this one has to be greater than. Wow, all right. So you can see that we just have a real small margin in here. If she really wants to make $90, this is the smallest, this is the area that she has to sell in order to make her $90. Okay, so systems of inequalities may contain more than 2 inequalities. So let's see what that looks like. Here we have 4 different inequalities we're going to be looking at. So we're going to graph these and see what happens with these. All right, so first of all, we don't actually have to use the less than or equal to sign until we're actually shading in. So let's see. The first one is going to say x is greater than or equal to -2. So what does that one look like on the graph? Well, let's see. X is equal to -2. So let's go over to -2, and we can see that it's going to be here. And it says it's equal to, so we're going to have a solid line, and there it is. I'm going to erase my line. And it says that x is greater than, so let's shade on the greater than side. There we go. The next one is x is less than or equal to 3. So x is less than or equal to 3, so we're going to find where that is. Here's x is less than or equal to 3. All right, so we're going to shade all of that in that direction. All right, the next one says y is greater than or equal to -x plus 1. So when x is 0, y is 1. And we're going to go down 1 over 1. There we go. And this is, again, a solid line. There it is. And this says it's greater than. So we're going to shade everything up above. There we go. And finally, y is less than 4. So here's our y is 4, all right, and it's greater than or equal to, so that's going to be a solid line for us, and it's going to be shaded everything down. So as you can see, there's one area that got shaded every single time, and here it is right there. And so that tells us that our solution set is this overlapping region. There it is. The solution set is the overlapping region. All right, let's try another one like that. Actually, why don't you try this one on your own? Turn the video off for a minute and then give it a try and then come back. And you will need graph paper to do these, so you might want to have some handy. All right, so the first thing we want to do is graph x equals 6. And so in order to do that, if this is 4, 5, 6, and it is greater than or equal to, so there's our first line. It says that x is less than or equal to, blah. And so let's shade in less than. Actually, we didn't shade this one in yet. The next one, y is 1/2 x plus 1, and there it is. And then when you graph the next point, y is greater than or equal to negative 2x plus 4. So there's that point. And now what happens when we shade everything in, let's see, x is less than 6. So x is less than 6. That's going to be this piece right here. It says y is less than 1/2, and so that was this piece right here, this red one down here. So again, we get to shade that part in. And y is greater than this last line, and once again, we'll shade just this area in. So that is our area of overlapping. So that's our region. So the overlapping region is the solution region, and the solution is a triangle in this case. All the points that are contained within that triangle. All right. And let's try another one on your own. All right. So when we graph these, we see we're going to graph a solid line boundary of y equals 4. So here's our 4. So there it is. And I'm going to go ahead and shade this in. Let's see if I can do this. Let's see, it says that y is less than that, so we're going to shade everything in this way. All right. The next point says y is greater than negative 1. So here's our negative 1, and so y in this case is going to be there, and we can graph that one. For some reason I don't have any more. Oh, I know, because I did that. Okay. Let's see. There we go. And there's our last point. So there's all of our points, and you can see if you shaded everything in correctly. Let's see here. Goodness, sorry. All right, so when we shade everything in correctly, it actually becomes right there. And so the overlapping region is the solution region. And let's just talk about that solution region. The solution region is a four-sided figure, or a quadrilateral. Notice that the boundary lines y equals 4 and y equals negative 1 are parallel horizontal lines. The boundary lines y equals negative x plus 8 and y equals 2x plus 2 are not parallel, since the slope of the first is negative 1 and the slope of the second is 2. So what does that tell us? Well, it's a quadrilateral with one set of parallel sides is called a trapezoid. The solution region, therefore, is a trapezoid. And that is the end of our lesson today. And our Bible verse is, "Let not your heart be troubled. You believe in God, believe also in me." That's John 14:1. So I hope you have a great rest of the day, and I'll see you in class. Take care.